It's great to be here. I really enjoyed the talks yesterday. I am a physics professor at Cal Poly and one of the co-founders of Project Jupyter, and want to talk to you today about reproducible, scalable, and collaborative data science. And I'm going to be giving the talk in Jupyter Lab, and as part of the talk, be demoing Jupyter Lab. But before that, I want to give you a sort of a big picture of Jupyter and the work that I've been doing. So some of the open source projects that I have been involved in, ZeroMQ and in particular PyZMQ, which are Python bindings to this. Underneath the Jupyter Notebook, there's a fairly complex distributed network architecture. And so before we built the Jupyter Notebook, we spent a lot of time at sort of the low-level plumbing and architectural level. As with my physics hat, I've worked on symbolic quantum computing as part of SymPy. And then IPython and Project Jupyter are my main activities these days, but recently have also co-founded Altair with Jake Vanderplas of the University of Washington as a statistical visualization library for Python based on Vega and Vega Lite. So an outline of the talk, I'm going to give you an overview of Project Jupyter, some of the challenges that Project Jupyter is attempting to tackle, and then how we tackle those in a few of our sub-projects. So Project Jupyter exists to develop open source software, open standards and services for interactive and reproducible computing. I want to emphasize that everything I'm going to talk about here is fully open source, released under the revised BSD license. And the big focus here is on interactive computing. So what do I mean by that? It's really illustrated in the Jupyter Notebook, which is the flagship application that Jupyter has built over the last few years. And the idea of the Jupyter Notebook is that of a computational narrative. The way that I think about this is that computers are optimized to produce, process, etc., data and code. Humans, on the other hand, we are evolved to think about and process the world in terms of narratives or stories. And so for data and code to be useful for humans, we need to embed them in some sort of narrative that helps us to make sense of them as humans, enables people to tell and consume and share and collaborate around stories that involve code and data. So here's a screenshot of a Jupyter Notebook. It is a web-based application. You can think of it conceptually, if you've never used it, as something similar to Google Drive, but with live code in over 100 different programming languages. So that's the core sort of main application that Jupyter has become well known for. The documents are JSON files that sit on your file system or in Postgres databases or on S3. You can email them with people. You can version control them on GitHub. And they are agnostic to the programming language. So they work, again, for essentially any programming language. And they encapsulate both the code, the outputs, markdown text, equations, and bundle all of that together in a single entity that you can share with other people. So how is Jupyter used? We have a very large and increasingly international community of users. Here's the Google Analytics page back in September of 2017. One thing that's notable is the sort of rapid internationalization over a very short period of time, over the last few years. The sort of audience has shifted from being primarily US, Canada, and Western Europe to being a truly international audience. We don't track installation of our software, so it's difficult for us to get an exact number of users, but it's definitely in the many millions. One of the ways that people share Jupyter Notebooks is on GitHub. GitHub renders Jupyter Notebooks inline, so you don't see the raw JSON data, you see a nice document format. They also index these as part of their search and trending, so there is a trending page of GitHub, of Jupyter Notebooks on GitHub, which a lot of people use to sort of follow what interesting work people are doing in the area of machine learning and AI. Just a warning, if you visit that page right now, it is broken. So it will not show you trending Jupyter Notebooks, and we're trying to work with them to get that fixed. One other proxy for the usage of Jupyter is the number of public notebooks on GitHub. This is a plot here We periodically monitor this, and sometime in the last month or so, it's crossed the 2 million public notebooks on GitHub. From our talking to them, our guess is that there's twice that in total, in that there's likely another roughly 2 million public notebooks on Jupyter on GitHub as well. We're seeing very strong organizational usage of Jupyter. This is another big change in the last 18 months. It's being used in data science platforms, data journalism, publishing, K-12, university education, data science, machine learning, AI teams in industry. Really here, it's sort of countless. A few years ago, I was in New York City and was talking to Hillary Mason, who's deeply embedded in the machine learning scene there, and I asked her, just curious, like how many, who do you know in New York City is using Jupyter for these things? And she laughed and said, are you kidding? Everyone. So there's very deep penetration. The two main tools in our sort of observation that these sort of commercial machine learning AI data science teams are using are Jupyter and RStudio. Those are really the go-to tools. And in many, if not most teams, the teams end up using both of those tools together in a complementary way. As well as it's used in large-scale scientific collaborations. What this means is that we have an amazing community of users doing mind-blowing things. So for example, the LIGO and Virgo collaborations won the Nobel Prize in Physics in 2017. All of their discoveries are accompanied on their Open Science Center by a set of Jupyter notebooks that completely reproduce all their analysis. So you can go look up the LIGO Virgo Open Science Center, and there's buttons there that you can click, and it will launch that notebook in a live computational environment in the web browser on Azure Notebooks, and also a service that we run called Binder. The Chicago Tribune was a finalist for a Pulitzer Prize this year, and the work that they had done was data journalism, and the underlying analysis was done as a Jupyter notebook. So here's a screenshot of the Jupyter notebook with data visualizations, narrative text posted on their website as part of the reproducibility of that data journalism. Other examples here, the notebook is being used extensively as supplementary materials in academic publications. Gene Pattern is one of many large-scale scientific collaborations that are using it. The data biosphere that was mentioned here yesterday, and then it's also being used by publishers to create actual books. So here's Jake Vanderplas's Python Data Science Handbook, which ships with a set of Jupyter notebooks with all of the code samples on GitHub. So what are the challenges in this area? The first is human-centered design. If you don't design for humans, you will design for computers, and humans will be miserable. A few such examples. Still today, the primary, quote, user interface for working on a remote computer is SSH. Tracebacks are still used to communicate to users almost universally when a program raises an exception. Exception tracebacks violate one of the most fundamental things that humans have learned about reading text. You start at the top and you go to the bottom, right? That is not true about tracebacks. And whenever I teach students, I have to teach them that. Actually, you want to go to the bottom and then work your way up to the top, and actually sometimes jump to the top. And it's a miserable experience. For more entertaining and depressing examples, I encourage you to check out one of Alan Cooper's books, The Inmates Are Running the Asylum. And I want to emphasize here that the part of data science and machine learning that I'm talking about is fundamentally human-centered, right? I'm not talking about massively parallel, operationalized data science. I'm talking about the part of it that involves iterative exploration, analytical reasoning, visualization, humans doing mathematical abstraction, model building, moral and ethical reasoning, and decision making. By definition, it is fundamentally a human-centered activity. The second challenge is this: massive data sets and distributed cloud-based architectures. Obviously, compute and storage need to scale along a number of different dimensions. for data processing, querying, and storage systems. You may be working interactively in a Jupyter Notebook, but be making calls through a Python API to BigQuery, for example. You may need to scale up interactive exploratory data analysis, visualization, etc. Now, if you just have one individual doing that activity, you don't really need to scale it up much. However, if you're working in a large organization where those things are being done by many, many people, just the interactive part of data science, machine learning, and AI needs to be scaled up in very non-trivial ways. An example of that is that UC Berkeley is now teaching data science eventually to the whole campus, right? And so you are going to need to scale up interactive computing, and they are doing this with Jupyter to the entire campus. They just launched an edX variant of their Foundations of Data Science course earlier in April, serving 100,000 students, all working interactively with Jupyter as the foundation for that. The challenge, though, with the cloud-based architectures that are enabling a lot of this is that the users are not sitting on that computer, right? They are sitting on a laptop at Starbucks somewhere. They are on a plane. They are somewhere over there. And this architecture that all of us have adopted essentially guarantees that the user will be far away from the code, the data, and the compute resources, right? And so traditionally, this has involved users and people building these systems making fundamental trade-offs, or very harsh trade-offs, where you can have the high performance and the cloud-based architecture and petabytes of data and SSH, or you can have a fantastic user experience with this 1 megabyte CSV file, right? This is the fundamental challenge that Jupyter is trying to solve, right? To give you both worlds at the same time. Usability, human-centered design, and a user experience that humans enjoy with all the benefits of the cloud-based architecture. So this architectural pattern has led to a proliferation of one-off user interfaces for datasets, machine learning libraries, databases, etc. I know you've seen this. Any conference you go to now and for the past number of decades is full of these one-off user interfaces, right? Some of them look like a little text area where you can type SQL code and then somehow get a result back, right? That's one such example. These types of approaches are limited, there's limited reuse, limited integration with other tools, a painful user experience, and those one-off user interfaces are costly to build, deploy, and maintain. The last challenge that I want to briefly mention is something that we are seeing happen very quickly, and that is as organizational adoption of machine learning and AI increases, I think everyone is beginning to acknowledge that while data science, machine learning, et cetera, have grown up and sort of made a lot of advances with open public data sets, in practice, most organizations have data sets that are at some level sensitive and confidential and need to be protected. That is a fundamental statement independent of any regulation or compliance aspects, legal aspects, although a lot of companies right now are struggling, let's say, to deal with the rapidly approaching realities of GDPR in the EU zone and more broadly. And so there's sort of fundamental questions there, there's legal questions, and then there's also ethical questions, right? I think by now everyone is aware of what's gone on with Cambridge Analytica obtaining the Facebook profiles of many millions of Facebook users and then building models that were used then to target voters in the 2016 US election. One thing that I think is worth noting here, you probably saw the press and they used Christopher Wiley, I think is his name, used the phrase build models when talking about the work that he was doing at Cambridge Analytica. And let's not kid around, what he was talking about was starting a Jupyter Notebook and typing import scikit-learn. If you're doubting that, here is the GitHub org of SCL elections that's affiliated with Cambridge Analytica, and they're deeply embedded with Jupyter, right? So we can't, on the open source side, pretend these are just tools. They're just neutral. People will do what they do with tools, right? Tools are created, and they're used in a context, right? And the context that we now have to deal with is that of private and sensitive data, right? So this is a fundamental challenge that we have to solve. So how are we dealing with this? I'm quickly running out of time. I want to show you a little bit about Jupyter Lab. So Jupyter Lab is the next generation user interface for Project Jupyter. It has full support for Jupyter Notebooks. This is Jupyter Lab here. It has support for notebooks, terminals, text editors, file browsers. And at this point, I'm going to switch to a live demo. So one of the abstractions that Jupyter Lab has is the ability here in the file browser to see all the files on a particular storage system. Currently, I'm on my laptop, but this could be connected to a remote system deployed on Google Cloud with Kubernetes, et cetera. So these files don't necessarily have to be on a file system. Even they could be an S3, a Postgres database. So here is a classic Jupyter Notebook. Again, Jupyter Lab still works with the classic Jupyter Notebook. If you've never seen the Jupyter Notebook, this is an example of it. This is a notebook going over a basic tutorial on convolutional neural networks using TensorFlow. Some of the big ideas is narrative text, visualizations, diagrams, combined with live code, in this case Python. Right? So that's an example of what the notebook looks like. Other things that Jupyter Lab has, a full-blown terminal, right? So you can run anything that you need on a remote system here in a web-based terminal, right? So you can run VI, Emacs, anything that you would want to do. The only thing you can't do is forward X windows, but one of our DevOps people recently showed me, hey, I've got a VNC connecting into a Jupyter instance, so you can run MATLAB GUIs if you want to do that. We also have a text editor. It is not a particularly powerful text editor, but compared to SSHing into a remote system, it is transformative, right, to have an actual text editor. So text editor. And then one of the big ideas that we're pushing with Jupyter Lab is integration between these different components. For example, maybe I want to take this Markdown file and show a live Markdown preview, right? So I can right-click and see the Markdown preview, put the two things side by side here. And as I edit this, I can edit this. The second I stop typing, over here, I don't know if you see that, the Markdown preview is updated. In Jupyter Lab, everything is based on well-separated models and views. You can attach multiple views to a single file. And so here we're seeing the live Markdown preview update as I edit the Markdown file. Another point of integration is, again, the emphasis here is live interactive coding. I can create a code console for this text file. Let's put it here. And then I can start to select a block of code and hit Shift-Enter, and it runs it live in that console. It will actually also do automatic code block detection in Markdown, looking for the triple backticks. So if I just put my cursor anywhere in this code block and hit Shift-Enter, it will run that code. Right? So there's a pandas data frame, and then I can actually make a nice plot here with matplotlib. Let's import scikit-learn, and just to show you some of the things, live tab completion. Again, the focus here is on this sort of exploratory data analysis, the interactive exploratory workflow that all people working in data science, machine learning, et cetera, need. But in a way that tackles this sort of massive gulf between user experience and these distributed, massive cloud-based architectures. Another thing that we've done is to abstract out the idea of file types. And so one thing we've observed is that oftentimes people want to write code. And when you want to write code, it is likely the most effective and productive and efficient way for you to be working. However, there's some things where you really don't want to write code, but you're sort of forced to. A great example of this is in a situation where you just want to look at a CSV file, right? You don't really know what's in it. It's the first time you've seen it. In JupyterLab, you can just double-click on a CSV file and change the delimiter and actually have a look at the file, right? Again, you could write pandas code or import it in R or something like that, but it's painful, right? So it works for small CSV files. So one of the emphases here is augmenting the writing of code with human-centered user experiences. So let's look at a few other file types here in data. So I can just double-click on an image, right? And I can instantly zoom in, zoom out. A lot of people working with data have images, right? So it's really nice to be able to look at the images. I could have terabytes of images on a remote system here and just double-click on any of them and see them, right? Here is an example of a GeoJSON file, right? So it's a JSON file. I can double-click on it, and we have built a renderer for that file type that immediately displays the GeoJSON on top of a Slippy map. In this case, we're using Leaflet, right? Now, I can still, if I wanted to, open that file with a text editor. It's probably not what I want to do in this case, but both views of that file are possible. Or maybe I'm doing bioinformatics, and I have a file with the genome, in this case of Zika. Again, we've worked with someone who built a simple renderer for that, and you can just click on your file here, your FASTA file, and immediately see this. JupyterLab is an extensible platform. Anyone in the world can build extensions for JupyterLab using modern web technologies such as NPM, Webpack, React, Angular, etc. Right? So a lot of the things I've shown you here are third-party extensions that other people have built in a fairly short period of time. Another example in the data visualization space, this is a Vega Lite JSON file. So I can right-click on this. I can open it in the editor to sort of show you what the underlying JSON data looks like. We have a renderer for that. And in the same way that Markdown had live previews, the same is true here. So I can just edit that JSON file and change to a point mark, and the visualization updates automatically. What I want to emphasize here is that this ability to have multiple views connected to a model works for any file type, right? So instantly, for example, there's another extension that one of our postdocs at Berkeley built for editing LaTeX. And as you type the LaTeX, every time you save the document, it automatically re-renders as the PDF here in JupyterLab. So I am essentially out of time. I want to scroll to the bottom and just give you an example of sort of how Jupyter is being used. So this is the LSST collaboration, the Large Synoptic Survey Telescope. This is going live in a few years here. I don't remember the exact date, but it's actually getting close. 2022, okay. 27-foot primary mirror, 10-year operating period. So this is focused on taking very large-scale pictures of the universe. So each image covers 40 moons worth of the sky, and it will be 15 terabytes of data every night. And the computational research platform that they're building is based on JupyterLab and Jupyter Hub. And I asked them, so what is the user base? And they told me, essentially every astronomer on the planet. Right? If everything goes as planned, LSST will completely transform astronomy. So they're looking at around 7,500 users. Those users are not going to be downloading this data set, right? They're thinking roughly a 3 petabyte relational database and 4 petabytes of flat files, scalable compute, 2,400 cores, and scientists want to work interactively, right? They want this interactive experience, and so that all of this will be based on Jupyter Hub, which is our version of Jupyter optimized for large-scale organizational deployments of Jupyter. And here, for example, is a screenshot they sent me of some of the LSST analysis libraries running in JupyterLab above a terminal. And to end, I want to emphasize that there's a very large community of people involved with Jupyter and all doing amazing things. And so I'm honored to present on behalf of this larger community, and thank you.
Thank you very much, Brian. Any questions before I serve up my softball? Okay, very good. So, oh, you had one? Very good. KT?
There was a recent study that looked at all the public GitHub Jupyter Notebooks and found there's a huge number with zero text. So how do you reconcile that with your narrative?
Yeah, so the reference here is to a study that was done by Adam Rule and Jim Nolan at UCSD in the design lab there. They downloaded all those I think 1.3 million notebooks from Jupyter or from GitHub, and then looked at them from a design perspective, in particular thinking about questions of narrative. And what they observed is that there's a lot of notebooks that don't have any narrative text. The way I'm thinking about this is tools for building narratives need to have very few constraints. And for example, if you could do a similar study of everything that people have typed into Google Drive, a lot of those documents wouldn't look very much like a narrative, right? It would sort of look like a scratch pad. We're probably seeing that type of behavior where people start to build a narrative, take notes, and then abandon it and go do something else, similar to how all of us use Word and Google Drive. So that's my interpretation. Fantastic research, though. I encourage you to have a look if you've not seen that. Yes?
People can write great code in Assembler and write terrible code in Jupyter, just like...
Oh, absolutely, yes, yeah. Most certainly. Yes.
Right. So the question I have is, in my one of my previous positions, we used Jupyter Notebooks for presenting and sharing information, and we had some difficulty doing version control on the notebooks because the results of computations, and especially graph images, are embedded in the output format. Have you looked at the possibility of separating the output so that you could possibly ignore the, well, not ignore, but not track that in a version control system?
Yes. A couple quick things to mention. One, we're working on real-time collaboration. So you could work with multiple people without version control, similar to Google Drive. Second is that there's a library called NBDIME, which stands for Notebook Diff and Merge, that provides a custom Git diff and merge tool that makes diffing and merging notebooks much more pleasant, and you can ignore the output in that. The third is that we're beginning to explore notebook formats basically in formats that are more friendly to version control, namely YAML, and making it optional to store the outputs as separate sort of sidecar type files. So this is something we're hearing from a lot of people and that we're actively working on.